man from Nepal used to ask me lots of questions like difference between the color red and blue, green and yellow, difference between the height of a car and a bus, and on and on and on. These kind of questions used to puzzle me, not in a sense of unknown answer. Rather, I was not able to explain answers properly to him. You may find these questions senseless. What if I say darkness was the only color he had ever seen? His height was the only height he ever truly felt. Yes, my friend, he was not blessed with vision. Like him, there are thousands of people who are not blessed with vision, and there are thousands of people who lose the gift of sight during their lifetime. World Health Organization estimates a total of 39 million people who are blind and 531 million people who have visual abnormalities. Can you imagine how hard the life would be without vision? As a child, I always wondered, what if Ram could see? How his perspective towards the life would change? How much opportunity would be there for him and his family? Later on, I had a new friend, Champa. During our period of friendship, she accidentally became blind. Luckily, she could regenerate the retina and get her vision back. Amazing, isn't it? But the contrasting factor here, my friend, was a newt, not a human. I, along with the like-minded people, started wondering, what if humans could do the same? Retina is an important part of eye that's responsible for vision. Destruction of retina, either by disease or physical injury, leads to the irreversible loss of a sight or blindness. Current treatment is only able to slow down the rate of retinal deterioration, but none will restore the vision. In contrast, newts, the amazing creature from the nature, is able to regenerate the whole functional retina from a layer of a cells called retinal pigmented epithelium, or RPE. RPE is a monolayer of epithelial cells that has an important role in a visual cycle. What happens is RPE loses its epithelial characteristics and starts detaching from each other and from the basement membrane known as the Bruch membrane. This gives rise to the individual RPE cells expressing multipotency marker. That is, now the cells can differentiate into the different cell types. These individual cells are called RPE stem cells, which gives rise to the pro-neuroretinal cells and pro-RPE cells, which ultimately gives rise to the functional neuroretinal cells and functional RPE cells. In the other word, the newt gets its vision back. Interestingly, adult human RPE also undergoes the similar initial regeneration process, but ends with the formation of scar tissue, some undesirable end product. This can be taken as boiling of an egg. Once the egg boils, to the knowledge of a science, we are not able to unboil it back. Similarly, once it ends with the formation of scar tissue, we are not able to revert it back into the functional retinal cells. As a result, vision is lost forever. So the question arises, what can we do now? RPE65 is an important protein that is responsible for maintaining the visual pigment regeneration in the photoreceptor cells or light receiving cells. So I aim to insert RPE reporter construct in RPE65 gene using the latest genome editing tool, CRISPR. Meet Geeta. She is our companion to unfold the mystery of retina degeneration. I will electroporate the zygote of Geeta with a standard CRISPR solution. This will give rise to the genetically engineered mice pups. Let's assume Musso Senior and Musso Junior are the two pups with the desired insertion in the desired gene. Now, the RPE of these mice will have green fluorescence in these cells, and any cells that descended from these cells will again have the same green fluorescence. As a result, the development of the cells can now be traced, known as the lineage tracing. Activation of the desired gene and inhibition of the undesirable gene, similar to that of the newt retina regeneration pathway, shall be done by using the mutated form of the CRISPR known as the dead CRISPR. This is supposed to create an ideal environment for the development of the retina, as pathways can now be highly regulated and phenotypes can be observed directly. This will help us to unfold the mystery of retina regeneration, opening the avenue for the regenerative medicine to cure blindness. Concluding in a sentence, we are trying to find inner newts within ourselves. Thank you.